Welcome to the next lecture. So now that you're comfortable working with Markov chain Monte Carlo and you understand the Metropolis Hastings algorithm, it's time to dive into the Gibbs samplers. So the Gibbs sampler is really just an extension of the Metropolis Hastings algorithm, and there's actually a great paper out on the Gibbs sampler by Gisela. I really recommend that you read it. If you don't understand all the math, don't worry about it. I'll try to explain most of the fundamental concepts in this lecture. So let's continue. So let's start with the two-stage Gibbs sampler. So the two-stage Gibbs sampler works by creating a Markov chain from a joint distribution where we're able to calculate the conditional distributions and then sample from one, use that sample to sample from the other, and et cetera, et cetera. So in this algorithm, we start out with some initial starting value, just as in the Metropolis Hastings algorithm. Then, using this initial value, we plug it into this conditional distribution to sample y, and then we take this y value and use it to calculate the conditional distribution for which we can sample for x. And then we sample for y again, and then for x. Always updating those x and y values as we're also updating those conditional distributions. It's as simple as that. So let's see this in action. So we're going to try to sample from a bivariate normal distribution. So we want samples for x and y, where both x and y come from a joint distribution. So if you've not seen the multivariate normal distribution, you should know that there's a link here to familiarize yourself, but we can also calculate the conditional distributions especially for a bivariate distribution. And the bivariate distribution, the conditional distribution for y and x are just normal distributions with a given mean and a standard deviation. So as we're sampling, we're going to be updating these means and standard deviations so that we can then sample from normal distribution. So let's put some numbers to this bivariate normal distribution that we want to sample from. So we have a correlation value, a mu, and a standard deviation. And we need to calculate some parameters for the conditional distributions. So we're going to get some starting values, and these are just going to be the averages of those bivariate distribution. So I start with y. So in my for loop, I get my y value. I update the average for the conditional distribution for x, and then I sample x. I store this x value in my matrix, and then I update the mean for y. And then with that updated mean, I sample a new y value. And I store it, and then I repeat. So with this y value, updated y value, I update the mu, sample x, update my mu for y, and sample y. And keep doing that over and over again. I think I set the for loop to run for like 10,000 or 100,000 iterations. And just to check, I can also calculate the means of my columns, which are basically 1 and 2, which correspond to what the theoretical values I set to be. And I can also calculate the correlation between the two variables, and you can see that's almost 9. So Now we can visualize our samples, and you can see that they look pretty like they're coming from a bivariate normal distribution. So nothing surprising, since we know that our Markov chain was well specified. So let's visit our old friend Beta-Binomial. So let's say we wanted to sample from the conditional distribution of x and the conditional distribution of theta. Well, we could just simply apply the two-stage Gibbs sampler to solve this problem. So distribution for x will just be this binomial distribution with that's conditioned on theta, and the distribution for theta will just be this beta distribution, since the posterior for theta is beta distribution. So for our algorithm, we're first going to sample x, and then we're going to use those x values to sample from theta, and then use that updated theta value to sample from for x, and continue on forward until we run out of things to do. So now I'm just going to set some parameters up for this problem so that I have an experiment to run, and I start my for loop. And just like I said, we're going to sample for x, and then we're going to sample for theta. And we're going to do this a bunch of times. And then just to see what results we get, I computed the quantiles for each distribution. And then we can visualize the marginal conditional distributions for each. So that was a two-stage Gibbs sampler. The Gibbs sampler can be expanded to handle any number of parameters. So for any scenario where we have a number of parameters greater than 1, we can apply the Gibbs sampler. And the multi-stage Gibbs sampler works by simply taking some initial starting values and sampling from one conditional distribution, then using those values to sample from another conditional distribution, and doing this over and over again until we sample from every single conditional distribution. Then we rinse and repeat. So once I'm done here, I go back all the way to the top and sample from that very first conditional distribution using all those updated samples.